Dear students, this is Lalita Ramachandran welcoming you in the section Differentiation of Laplace Transforms. In this session, you will get yourself introduced with the theorem of differentiation of Laplace transform, its proof, and the concept with few illustrative examples. The theorem of differentiation of Laplace transform or multiplication by t power n. Let us look into the statement of this theorem, which says if capital L f of t is equal to capital F of s, or the Laplace of the function f of t is equal to capital F of s, then Laplace of t power n f of t is equal to minus 1 to the power of n d power n by ds power n capital F of s, where n carries the value 1, 2, 3, etc. Let us move into the proof. By the definition of Laplace transform, we very well know that capital F of s could be defined as integral 0 to infinity e power minus st f of t dt, which is equal to Laplace of f of t. Now differentiating both the sides with respect to s, we get d by ds capital F of s is equal to integral 0 to infinity minus t e power minus st f of t dt. When further simplified, we get minus integral 0 to infinity e power minus st into t into f of t dt. So, we get d by ds capital F of x to be equal to minus Laplace of t f of t. You can refer the definition to understand this, and hence we conclude Laplace of t f of t is nothing but minus d by ds capital F of s. Differentiating one again with respect to s, we get d square by ds square capital F of s is equal to minus integral 0 to infinity minus t e power minus st t f of t dt. When further simplified, it could be written as minus 1 the whole square integral 0 to infinity e power minus st into t square f of t dt. Now recall the definition of Laplace transform, and hence we write it as minus 1 the whole square Laplace of t square f of t. Therefore, here we conclude that Laplace of t square f of t is equal to minus 1 the whole square d square by ds square capital F of s. So, we proceed this for n times and we get Laplace of t power n f of t is equal to minus 1 to the power of n d power n ds power n capital F of s, which could be also written as minus 1 to the power of n d power n divided by ds power n Laplace of f of t for n taking the value 1, 2, 3, etc. Now we move into some examples to understand the concept far better. Let us find out what is Laplace of t cos 3t. So here we observe that it is into the form of f of t multiplied with t. So the rule of multiplication could be applied, which is Laplace of t power n f of t is equal to minus 1 the whole power n d power n divided by ds power n Laplace of f of t. So here n is equal to 1 and f of t is equal to cos 3t. So Laplace of t cos 3t is equal to minus 1 d by ds Laplace of cos 3t. Since we know that Laplace of cos at is nothing but s divided by s square plus a square, we substitute that formula and we get minus d by ds s divided by s square plus 3 square. So differentiating it, we get minus of 1 into s square plus 3 square minus 2s into s divided by s square plus 3 square the whole square. When further simplified, we get minus 9 minus s square divided by s square plus 9 the whole square. Therefore, we get the solution Laplace of t cos 3t is equal to s square minus 9 divided by s square plus 9 the whole square. Let us move into our next problem to find out the Laplace transform of t into e power minus 4t sin 3t. So here we need to understand that the first term represents our t and rest of term represents our f of t. So very well we can use the formula Laplace of t power n f of t is equal to minus 1 to the power of n d power n by ds power n Laplace of f of t. So when applied, we get minus 1 to the power of 1 d by ds Laplace of e power minus 4t sin 3t. So here we see that first shifting theorem could be applied. So Laplace of e power minus at f of t is written as Laplace of f of t with the shift of s to s plus a. So we get minus d by ds Laplace of sin 3t where s is shifted to s plus 4. Since Laplace of sin at is equal to a divided by s square plus a square, we substitute and we get minus d by ds 3 divided by s square plus 3 square with the shift of s to s plus 4. We replace s by s plus 4 in our next step. So we get minus d by ds 3 divided by s plus 4 the whole square plus 9. So now differentiating this with respect to s, we get minus of 3 into minus 1 into 2 into s plus 4 divided by s plus 4 the whole square plus 9 the whole square. When further simplified, we get s into s plus 4 divided by s plus 4 the whole square plus 9 the whole square. Hence we get the solution for Laplace of t into e power minus 4t sin 3t to be equal to 6 into s plus 4 divided by s plus 4 the whole square plus 9 the whole square. Let us move into our last problem, that is Laplace of t square e power minus 3t sin 2t. So here also we need to understand that the first term could be considered as t square and rest of the term is in the form of f of t. So very well I can use the formula Laplace of t power n f of t is equal to minus 1 the whole square d power n ds power n Laplace of f of t. So when we apply it to the given problem, we get minus 1 the whole square d square by ds square Laplace of e power minus 3t sin 2t. So now here we again apply our first shifting theorem and we get minus 1 the whole square is nothing but the positive d square by dx square e power minus 3t sin 2t where s is shifted to s plus 3. Since we know sin at Laplace value is a divided by s square plus a square, we substitute and we get d square by ds square of 2 divided by s square plus 2 square where s is shifted to s plus 3. Now we replace our s by s plus 3 and we get d square divided by ds square of 2 divided by s plus 3 the whole square plus 2 square. So now we differentiate twice. So we get d by ds of 0 minus 2 s plus 3 into 2 divided by s plus 3 the whole square plus 2 square the whole square. We again differentiate it and we get minus 4 into 1 into s plus 3 the whole square plus 2 square the whole square minus 2 s plus 3 the whole square plus 2 square into 2 into s plus 3 into s plus 3 divided by s plus 3 the whole square plus 2 square whole power 4. So when further simplified, we get minus 4 s plus 3 the whole square plus 2 square into s plus 3 the whole square plus 2 square minus 4 s plus 3 the whole square divided by s plus 3 the whole square plus 2 square whole power 4. So when we cancel the terms, we get minus 4 into minus 3s square minus 18s minus 23 divided by s plus 3 the whole square plus 2 square the whole power 3. So when we multiply the negative term inside the bracket, we get our solution to be Laplace of t square e power minus 3t sin 2t to be equal to 4 into 3s square plus 18s plus 23 divided by s plus 3 the whole square plus 2 square whole power 3. So dear students, this is time for you to practice. Here are a few problems under differentiation of Laplace transform for you to get know the concept much more clear. Thank you so much for watching this video.